sharing here, which is plugged into the monitor. We'll hope this works without too much lag. Great. Yeah, a little delay. That's okay. And I'll probably sit at some point to drive here, but I'll start by standing up. Thanks, guys, so much for having me. I've been working with Carlo for the last 3.5 years or so at Tesla, and now at Pirelli, and it's great to be working with him, and it's great to be visiting you guys in Italy. I landed this morning from San Francisco, so apologies if I start to slow down a little bit due to jet lag, but I think I'll power through. I had a double espresso this afternoon. I'm going to talk about lessons learned from working with advanced data science organizations, and this is not going to be a technical talk for the most part. I know you guys get lots of those, and how to use TensorFlow or how to use whatever the latest packages and tools are. This is going to be a little more in the style of a TED Talk, and I'll move pretty quickly through some high-level points and concepts. Then I'll jump into what will be a shameless pitch for our products. But I will connect that demo to some of the bigger picture topics and concepts that I've been talking about first. Let's see. I want to do two things here. I mean, the first is seed in all of your minds to give you something thought-provoking to take back to wherever you work about, like I said, sort of some concepts or some ideas that you might be able to apply to the organization that you work with. Not so much about technology or a particular tool, best practices and processes for enabling more scalable data science practices. And then I'm going to share a strategy for how to implement some of those ideas. And like I said, I will talk about our product and how it sort of implements those strategies. But even if you have no interest in our product, I want to leave you with something valuable you can take back. Quickly about me, I started building Domino Data Lab about 4.5 years ago. We now work with about 100, mostly in the United States, but also out here in Europe and a couple in Asia. And I've been really fortunate in that position to get exposed to a lot of different teams and problem domains and get a sense of how they operate. I was in the finance industry. I worked at a big hedge fund, and I ran an engineering team there that built all the internal technology and products for data scientists at that hedge fund. And I have a background in computer science. So I was sort of an engineer by training, and then started building products for data scientists, and then now turned that into a product. Okay, I'm going to jump into kind of the lessons learned from advanced organizations. So the first thing that I notice all the time, a lot of data scientists think of their work as a solo job. They are a brilliant practitioner. They sit down, they do their work, they do their magic, and then sort of insights and models come out of that. The most effective organizations that we've seen in those organizations, data scientists view their work as contributing to a collective whole. And I think about this as, how does a company create a culture where they view their work as building a hive mind? So if one person knows something, then that knowledge becomes shared throughout the rest of the organization so that people don't have to reinvent the wheel or rediscover the insights that other people have had. And so the beehive image here is meant to sort of evoke that metaphor. One of the things we see a lot, just to make this concrete, oftentimes data scientists or teams will finish a project and they view their job as building a model or building a report or answering a question. And the best teams we've seen, that's not what their job is. Their job is to do that, and then when that's done, leave that work, leave that knowledge they've created in some state where other people in the future or other people around the organization can pick it up later and build upon it and benefit from it. So your job is not done until the rest of your organization or the future employees on your team can benefit from the work you've done, and that will make for a faster pace of scaling your organization. The next thing that we see, do these in a series of contrasting statements. We often there's sort of this notion in popular culture that insights come from these breakthrough aha moments or these epiphanies. And this is, Isaac Newton sitting under the apple tree, fell on his head, and he had this realization about gravity. Well, in reality, that's not how it works, and that's not how the best organizations are built. They're not built around that notion. And what we find in practice is that real progress, real breakthroughs come from lots of small insights that compound over time. So, every day people are making things just a little bit better, and just like compound interest, if you have money in a savings account, each of those incremental improvements build upon themselves and lead to a big result over time. And even Isaac Newton actually said, if I've seen farther than others, it's by standing on the shoulders of giants. And this is this idea that new projects, new data science projects never start from scratch. They never start in a vacuum. And just connecting back to that point about the hive mind, how do you equip your organization to be able to take advantage of all the past work and learning that have been done before? Next point we see a lot, and this is certainly something Carlo touched on. We hear a lot of organizations looking for these silver bullet tools and technologies, for the latest big data storage solution, the latest visualization, the latest package where we'll just upload our data and it has pre-built models that are going to automatically figure things out for us. And in reality, especially because the state of the art in the space is changing so fast, what's more important than any one particular tool is having the agility to rapidly experiment and test new tools, new techniques, to take advantage of whatever's coming next. And a lot of them won't work, some will work, but sort of as your organization geared to be able to take advantage of that. In contrast, we see a lot of organizations where there are somewhat stifling IT departments that make it hard for technical people, for data scientists to get access to new tools and packages that could be valuable to experiment with. And then the final contrast that I'll draw, somewhat related to the tools, the tools notion. Oftentimes we see leadership, senior leadership, senior executives, especially if they haven't come from a technical background, have this notion that technology is sort of like magical, that technology will solve all the problems, and that you just throw technology at things and that makes things better or faster. And if just extrapolating from some of the points I've made so far, what we've seen is that really the secret sauce or the key to rapid innovation and progress in an organization is not first and foremost technology. It is having a culture of discipline, rigor, rapid iteration, constant improvement. And it's these things I was talking about around how do you enable more collaboration? How do you enable more reuse of past work? How do you enable faster experimentation and the ability to build upon past learning instead of reinventing the wheel every time? And if you think of this as your goal, how do you create an organization that works this way with this discipline? Then we think kind of the best that technology can do is actually enable. So how can technology enable this kind of way of working? How can technology enable more collaboration, faster iteration, more discipline, more rigor? So you know where this is going. That's sort of what the idea is behind our products. I'll elaborate a little bit on these points, though. Stepping back, just to synthesize a couple of the themes I've touched on. The first one is around collaboration, and that means a few different things. That means, how do you enable a shared context? This is like when I talked about the hive mind idea, instead of having individuals working in silos. How do you make sure that if one person is working on something, other people know that? Without elaborate process to go through? How do you make sure that if one person has a better idea, or if one person improves a core component, other people are able to take advantage of that? Discussion is a big part of that. Search and discovery is a big part of that. Maybe all these great ideas, all this work other people have done are out there, but if nobody knows to look or nobody can find the work that's been done, then it's not really creating value in the organization. The next theme is around reproducibility and reusability. And software engineers have solved this problem. They solved it decades ago. They figured out, okay, we need version control, we need build systems, and build systems have artifacts that link back to what version of the code we actually compiled. It's a little different in a data science context, and some of those tools don't transport perfectly to data science work. And that's because in data science work, it's not just about having the source code. You need the data sets, you need the results that got generated. What were the performance graphs and curves, and maybe the models that we actually trained. And we need a notion of what were the actual, if we want to really reproduce something, what were the packages that we had installed? What were the versions? It's not enough to just have source code. But having this ability to reproduce and reuse past work is key to enabling what I described around building upon what's been done before, standing on the shoulders of giants instead of reinventing the wheel all the time. And then the third theme here is around agility and speed of iteration. And that actually, there are two versions of that, two flavors of that. The first is during the R&D phase of data science work. How do you more rapidly, maybe those new ideas, maybe you want to test new tools and packages, how do you get them into your organization quickly? Things that are computationally intensive, and you need access to scalable compute, burst compute, to try more experiments at once instead of waiting a long time. And what we found is that it's not about one person having one brilliant idea and building one great model. It's about how rapidly can you test and iterate and experiment. And then the second version of this notion of iteration is actually, okay, you build a great model, you build some great analysis or dashboard. How do you get that deployed or exposed or shared with business stakeholders, with existing IT systems in your organization, so that great work that you did as a data scientist actually connects into the business processes that are driving decisions in your organization? And iteration there is important because oftentimes that last mile can be a real bottleneck. You can build a great model and then it can take 6 months to get it really deployed out to impact production systems. So there's iteration, speed of iteration when you're testing ideas and building models, and then there's speed of iteration when you build a great model. How do you get it deployed to the business? And often if you're doing both of those loops really quickly, then the pace of progress in your organization will accelerate. So that's kind of my take on some recurring patterns and themes we've seen. There's a strategy we have pursued to address a lot of these problems nicely together. And like I said, even if, regardless of with our product, I think this strategy, this approach offers something valuable to take back to where you guys work, to think about how to build adoption of some of these best practices. And that strategy is to find a way to incentivize best practices instead of mandating them top down. This is I show this slide, and most people come up to me afterwards and realize they ask what it was, and I realize it's not that clear. This is a cupcake, obviously. On the cupcake, there are pills like medicine. And the idea is, how do you give data scientists something they want that gives them some instant, immediate gratification? And in the process of getting them to consume that instant gratification, get them to sort of take their medicine or do something that's good for them in the long run. And in this case, in our case, what we found is that you can give data scientists a central, sort of a central platform where you can automate infrastructure, you can make it easy to use new packages, you can let them scale their infrastructure and compute environments. And that makes them much more productive. That lets them scale their accelerate their experimentation, test ideas a lot faster. And the flip side of that, because they're using a central platform, what you can do is you can start to layer in these best practices. You can track their work. You can make their work searchable, discoverable. You can layer in discussion features in that central environment. And I contrast that to, trying to force data scientists to use version control or a wiki, Confluence. and sometimes that works and that's great. But oftentimes when there's a top-down mandate, you say, you guys all have to put your work over here. If there's no incentive, if there's no short-term incentive, then people won't adopt those best practices. So this is how we've tried to encourage it. So I want to do a quick demo. Do I have time to do a quick demo? Okay. I'm going to do a quick demo, and I'll show you how we have implemented that strategy. Our product is the Domino Platform. It's a data science platform, and it combines three things in a sort of a tightly packaged way. The first is a workbench that lets data scientists spin up compute environments, run common tools like Jupyter or RStudio, and also run batch experiments and model training tasks. And we automate infrastructure, and we make it easy to manage packages, so ops, and you can test more ideas faster. On the right side of this, we let data scientists package up and deploy the work they build so they can expose it to the business stakeholders more rapidly. We let them do that as publish things as APIs or as scheduled reports and apps and dashboards. And underneath all that, we keep everything in a central place in a collaboration hub. So there's discussion, there's search around past work, there's knowledge management. And these things together sort of implement what I was describing a few minutes ago. So let me do a quick demo. I'm going to sit down for this. Okay. Let's see. All right. Okay, this. You guys still hear me? Yeah. All right. So.
Yeah, increase the font. Maybe kind of.
Oh. Yeah. How's that?
Yeah.
One more.
Or reduce the resolution. Yeah.
Is that okay?
That's better. Yeah.
All right.
A little bit.
So there's a web interface, and to start out, you sort of just get files in here. So you can upload files from your computer. There's nothing special about the files we track. You don't have to move your work into some new format or migrate anything. And look, this can be scripts. This can be notebooks. We know how to render lots of different kinds of files. A quick show of hands. How many people are Python here? How many people are R? Good. Okay, you guys, you don't want to sit on opposite sides of the room or anything. So I'll sort of show something in both. But yeah, anyway, lots of different kinds of files or whatever you normally have in your project. What I have here, beyond sort of the files, when you're working in a project in our platform, we have a whole execution infrastructure behind the scenes here. And so let's say you're going to do some work. Either you're going to use Jupyter or RStudio, or you're going to run a Python script or an R script. We let you choose where that will run, what kind of hardware to use. And we can do this in the cloud, we can do this on premise. So with one click, you can say, I want to take advantage of a machine with a lot of memory, or maybe I want to use a GPU. I'm going to do something with neural nets. For this demo, I'm going to use our cheap machine. And the other thing we let you do, we let you define and centrally store and manage what we call a compute environment. This is the set of all the packages and configuration that you need for your analysis to run. Under the hood, we use Docker. You can customize what's installed in your Docker images. These are a bunch of ones in a demo environment, but you make these yourself. And the idea here now is that anybody working on this project, because you can have your collaborators and your whole team works on it, instead of having to get their local environment set up properly to match what you did, that's all stored in one central place. So if someone joins the team, they come back later, it's all set up and ready to run. And now when you set up that infrastructure, you've chosen what you want, you've chosen your hardware, you've chosen your software, you can spin up these interactive sessions or run experiments. And this is the workbench I was mentioning earlier. So with one click, I can say, I want to fire up a Jupyter workspace. And what we're doing here is we're spinning up a machine of whatever hardware type you asked for. We're launching a container on that machine with the packages you want installed. We're linking your project files in. And so, if I had chosen a big GPU or a high memory machine, that's what I would now be logging into. And then we'll just drop you into Jupyter. It's the same environment you normally work in, but this is kind of running through our orchestration layer. So when you make your changes, you can then save your work or get rid of your work, and then it'll all be committed and saved and revisioned back into your project so your colleagues can benefit from it. Works the same way with RStudio. So I'll say I want to fire up an RStudio environment. We'll launch a machine. Multiple people in your organization can have their own work going at the same time here. We'll elastically spin machines up and down. So Jupyter, RStudio, we support a bunch of other interactive tools if you want. The next thing that we do here is we actually let you run not just these interactive tools, but sort of batch scripts and experiments. And what I have here is a Python script that I took from the Scikit-learn website. And this does some topic classification of Reuters articles. I'm not going to go through all this. It trains reads a data set. It trains a model. It generates some plots to show how the model performed. It generates some statistics, like what was my AUC and a p-value, and saves them off to files and disks. And so it's all plain Python, nothing Domino specific here. Now what we can do is we can say, I want to run this. It takes a parameter, like how large of a training set should I use? So I'm going to kick off this experiment. And while that's running, maybe I want to try a different idea. And we talked about speed of agility, speed of testing ideas and iterating. So maybe I have two different variations of this model I want to run with different hyperparameters or different techniques. What I did is I kicked them off in parallel, and we actually spun up two different machines. And I could do this 5 times, 10 times. So now the speed at which you can test ideas gets much faster. You don't have to serialize your experiments. And remember I talked about a strategy of automating best practices or incentivizing best practices. Well, this is a great example, because from a data scientist perspective, we just got a massive speed increase. We didn't have to deal with DevOps. We could test more ideas at once. But what we've done under the hood, every time an experiment runs, anytime you work in Jupyter or RStudio, we automatically detect and snapshot and record what you did and the results that you generated. So here's that experiment I ran. Domino detected the plots that were generated. We detected the summary statistics that got produced. And now this is hosted centrally. So this makes it really easy to collaborate. I can say, would NLTK be better? And if we talked about shared context, collaboration, discussion. So now if someone joins this project, or a manager wants to get a sense of what's going on as the project's progressing, they can pop in and see that discussion organically. This also gives you reproducibility, because we know if someone's looking at this result set months in the future, we actually know exactly where this came from. We know this came from experiment number 7. And I can say, oh, I tried, that was the one I did with the parameter 730. If I want to get back to exactly what produced that result set, I can get back to the version of my files exactly as they were when I ran it. And now if I'm wondering, how is that better or worse than the latest version of this model I've been developing, I can actually compare my ideas, compare my experiments, and see not just source code changes, but complete results side by side. And so from the data scientist perspective, we got a productivity boost, but the organization as a whole got preservation of knowledge, reproducibility. And this is all just one project. If I zoom out here, we have all the projects that everyone's working on across the organization in one place. And so I can see what other people are doing. I can see that someone's doing some analysis right now on credit default risk project. Someone could see that I'm working on this Reuters NLP project. And if someone is going to start some new work and wants to see, what have we worked on before that might be relevant? Have we ever done anything with the Reuters data set? There's my projects. If someone's wondering if we have any examples of using NLTK, I can do a search. And I didn't find any projects, but I see that there's been some discussion about whether NLTK would be better for a past result. And if we wanted, this will index sort of all the files and everything too. If you want to find code snippets you could borrow that might give you an example to start with, so you don't have to go learn everything from scratch. So that's how we accelerate experimentation and we enable collaboration. So I've kind of covered here was the workbench and this collaboration hub. I just really want to quickly talk about publishing and deployment, and I want to be mindful of time here. So let's say you built a great model, you built a great analysis. How do you get it connected to the business now? There's a few ways to do this. The first is it's actually really easy to set up things to run on a scheduled basis. This can send reports or recompute dashboards or notebooks that get rendered for other people in your team. One of the things, there's a bunch of other things I can show, but in the interest of time, one of the sort of the real engineering accomplishments we're particularly proud of is an ability to deploy predictive models as production grade APIs. And the way this works, where's my, I know I'm jumping a bit here. So we talked about development, workbench, collaboration, and I'm kind of quickly rushing to tell you a little bit about the whole other side of this around deploying models as APIs. And in the first half of 2018, Carlo may not know this, we did a complete rebuild of how we do this to make it sort of production grade, enterprise grade. And basically the idea is we'll let you take your Python or R model you built or any Python or R function you've written, and with a couple of clicks, you can sort of package it up in a container. We will make sure that the same packages are installed there that you used when you developed your model, all the versions are right, and then we'll deploy it across a horizontally scalable infrastructure. We will enforce access controls, we'll audit and version control every time a new model is deployed. We'll put load balancing in front of that, and we'll log all the requests that come in and the responses that go out. And just to kind of show you a quick example here, this is since I did the last thing in Python, I'll do this in R. This is a really simple R function that loads a model we've trained in a previous step. And I've got a function here called API. It takes parameters as arguments. Those parameters are a map or a data frame that have different properties of iris species we measured. We try to predict what species it is, and then we return the predicted species classification canonical machine learning data set. And I've already, if I want to publish this as a model, it's really easy. I can click on this publish section here, and it's just basically 2 clicks. I say, my code is in a file called api.r. This could be whatever your script is that you've already written. And here's the function. This could be, predicts credit score, predict probability of a maintenance event if you're in manufacturing, whatever. In our case, it's the API was the name of the function. And I hit publish, and we do everything I showed on that previous step. We productionize it, we stand it up. I've got it running already. I don't want to wait for it to publish. I just want to show you what it looks like. So now you can sort of pass in a payload as JSON, and we will marshal that into your function. So we'll marshal this data structure into the R code or the Python code and this little tester UI, and then we get back a response that's whatever your function returned. So my function returned a species prediction, and that's what comes back in the API request. And it's low latency, high scalability, high availability. We generate code snippets you can use to invoke this from other languages. So now you can turn any R Python code into a microservice, a web service that your production apps can use. You can do lots of nice things here. You can scale how many instances this is deployed on. You can configure who has access. And every time you make changes, we'll keep an audit record of who did what. And we'll also log all the incoming requests and responses. So we can see, I just tested this here, and here's the response I got back. So that's kind of the idea. Full data science lifecycle, development all the way to deployment in one place that gives you best practices. It took a little longer than I planned. I'm going to be mindful of time. Let me pause and see if there are any questions. And would love it if you guys, if this looks interesting, please check us out. We've got a good blog where we write about this stuff too. So I can take questions now, or I can stick around afterwards as well.
Yeah. Anyone? Nick is not going to disappear, but if you have questions, feel free to ask right now.
Yeah.
Absolutely.
Okay, thanks, guys.